Hey there, PreCalc. Here we are with another fun and exciting lesson. 1.7 transformations. We've got vertical and horizontal shifts. Okay, so again, pretty similar to stuff from Algebra 2. If it is outside of the parentheses and it's a plus or a minus, that's going to affect your vertical shift. Okay, plus goes up, minus goes down, just like you would think. Okay, if it's inside parentheses with x, alright, that's going to affect your horizontal shifts, left and right, and those are opposite of what you would expect. So minus is actually going to go to the right, plus is actually going to go to the left. This looks a little funny. Maybe you would have seen it last year like this. A in the front, x minus h squared, plus or minus k plus k. Alright? In here, it's going left or right. Minus goes to the right, plus goes to the left. Out here affects up and down, and that's normal. Plus goes up, minus goes down. The A is going to stretch and or reflect, and we'll talk about those in a minute. Okay. So let's just talk about these, and then we can look at these on our graphing calculator. So x to the third is going to be our basic one. Our parent function that we talked about yesterday, 1.6 in our library of functions. What's this plus 5 on the back going to do? Okay, just a normal plus 5 on the back is going to slide it up 5 units. X minus 3 inside the parentheses cubed plus 2. Okay, the minus 3 is going to shift it 3 units to the right, and then up 2. So let's just take a quick peek, make sure we're thinking about that correctly. X to the third. Then we have x to the third bumped down plus 5. Parentheses, x minus 3, parentheses to the third. Bump it down plus 2. Okay. So there's our normal one in the blue. The red one's just slid up 5 units. Okay, and then the black one, our third one, we're 3 units over to the right and 2 units up. Original, plus 5, 3 to the right, 2 up. Okay, and that will work for basically all of them that we have that we're going to be doing today. Reflections over the y or the x-axis, vertical reflections over the x-axis, the negatives on the outside, and then reflections over the y-axis, the negative will be applied on the inside. Okay, so here's our normal x to the fourth graph. It's kind of it looks a little bit like a parabola, but it's really flat on the bottom here. It's not a very smooth U, right? Like a parabola, x squared one's going to be really smooth like that, and then this one's almost a box. Okay. So here's x to the fourth. What would this be? Looks like we're up 2 units and then flipped upside down. Think about how you would do that. There's no left or right. We're just up 2 units and then flipped upside down. Negative on the outside, x to the fourth, and then the plus 2. Okay, so negative, so we're flipping it, and then slide everything up 2. What about this one? We're still upside down, and now it looks like we're 1, 2, 3 units to the right. Flipped upside down and slid 3 units to the right. Negative on the outside. 3 units to the right, minus 3. Remember, it's opposite of what you want to think there. Okay, and there it is. Here's a fun one. Now we're going to see that negative on the inside. All right, so we're going to graph all 3 of these. Square root of x minus 1. Well, first off, what about just the square root of x? This is going to be slid over 1 unit to the right. Okay, this one's going to be 1 unit to the right and upside down. from the negative on the outside. Here's the negative on the inside. Okay, so let's you can kind of think about this negative parentheses x plus 1. If we kind of factor the negative out of both of those, but still inside. So what this is doing, thinking about this, we're going 1 to the left, and then this negative inside the function is going to flip it horizontally. So let's see what these are going to look like. Let's see if it kind of matched our verbal description there. So we're going to start with the x squared of x minus 1. Okay, we're also going to have negative on the outside, square root x minus 1. And then square root negative on the inside, x minus 1. We're going to see the difference here on all three of them. So there's our first one, slid 1 over to the right, just like we thought. And then the negative on the outside flipped it upside down. Okay, negative on the inside took our first one and flipped it horizontally. All right. So there we are. And we looked at that last one in a different way, like if we factor out the negative into the front, so it would slide it 1 to the left, and then that negative would change it from going this way to going this way. That's another way to kind of think about it. Okay, rigid transformations are horizontal shifts, vertical shifts, reflections. Okay, the basic shape of the graph stays the same or unchanged. It's just the position of it changes on the graph or on the XY plane. Okay, we didn't change the shape, we just changed where it was located. Okay, non-rigid causes distortion. So now we're going to be talking stretches and shrinks or compressions. And they're very tough to tell the difference between the two. They essentially do the same thing. So normally you just really talk about the vertical stuff because the horizontal ones are basically going to do the same thing. Okay. So if we have x squared, pretty typical one, right? If we take 4 times x squared, it's going to grow faster really quickly. It's going to be a lot steeper, a lot sharper. So we would go from that kind of a U to almost a really sharp one, almost a V. Okay, and a fourth, we're going to go from the normal one here. It's going to really flatten it out. We're going to grow really slowly. So it's going to make it look like that. All right, we can check it out. That's the beauty of the graphing calculators here. We can check these graphs out and compare them a lot quicker than if we had to actually graph each one out. X squared. Let's look at 4 times x squared, and then 1/4 x squared. So there's our original. Second one's a lot sharper there, and then a lot flatter on the third one. Just like we thought. Okay, what's going to happen now if I put that 2 times on the inside and that half on the inside? Okay, so now we're talking 2 on the inside squared. 2 times x parentheses squared. So here the multiplier was x squared, and then take that times 4. Here we're putting it on the inside, 2 times x first, and then square it. Well, if you simplify this, it's really going to be 4x squared, then that would be on the outside. So that's what I'm saying. It ends up being about the same thing. And a half x parentheses squared, and they have a +3 on it this time too. So that ends up being about the same thing, guys. X squared +3 parentheses 2x squared +3 parentheses 0.5x squared +3. So it's going to end up being about the same stuff, because you could simplify it and we get the constants on the outside. So there's your first one, second one, third one. It ends up doing the same thing. But because these are on the inside, now we're talking about shrinking and stretching it horizontally. Whereas before, you're talking about it vertically. That's what I'm saying. For the horizontal ones, for a lot of them, you end up talking about it vertically because you can simplify and then pull those constants on the outside. Okay, but in general, there we are with our, if it's on the inside, the shift, left and right, opposite of what you're going to think. A minus is going to go to the right, a plus is going to go to the left. Constants on the outside of the function, outside of the parentheses, vertical shifting, and that's going to do exactly what you would think. Minus goes down, plus goes up. Negative sign applied on the outside of the parentheses is going to reflect it over the x-axis. Negative sign applied inside the parentheses reflects it over the y-axis. A multiplier applied on the outside of the parentheses is considered a vertical stretch or shrink, and a multiplier applied on the inside of the parentheses is considered a horizontal stretch or shrink. So there you go, folks. Section 7. Let me know if you got any questions. We'll see you later.